Hello guys and gals, welcome to a new tutorial. In today's tutorial we're going to be going over a Toony outline effect like the one that you can see in this current scene. You can see here we've got this black outline going around the tops of the trees, down some of the trunks, around some of the rocks. The way this works is that it looks for vertices within the screen space. By dividing the screen space into a grid, it takes verts within each part of the grid, flattens those down into a set of new UVs. Then it removes anything that isn't vertice from the scene depth and uses the vertice info in that scene depth to map out an outline, like you can see there. It's very maths heavy. You can see the same kind of thing in the Unreal Engine's Learning tab under the stylized rendering. That inspired this current project. This was one for university last year. So you can see the same thing there. I've taken it, I've broken it down, I'm going to explain it to you guys and run you through how we set that up and why it works the way that it works. And hopefully you'll learn something new and you'll be able to use this. So let's hop into it. I'm in a new project here. It's just a third-person template. Yay, third-person template. My favorite template. Don't know why, it's just my go-to for testing. We're going to right-click, Material, Outlines, _M. We're going to open this up. The first thing we're going to do is change the material domain to post-process. That's going to disable everything except for emissive color. And we don't want that guy for a while, so we're just going to abandon him and leave him over there. So, right-click. We're going to go for a no, we're not. We're going to go for a screen size. It is screen size. Come on, screen size, right? No. Where are you at? View size, not screen size. We're going for a view size. After a good start. Woo! Let's continue that way. Then what we're going to do is we're going to divide this by a flat number. So we'll hold 1 and left click. Plug this in. We're going to set this to 256. This is going to allow us to get a power of 2, which we're going to then do. So we're taking the screen size and dividing this by a power of 2. What that's going to do is give us essentially squares. Kind of like a grid. We're making a pretend grid. We're going to hit this with a ceil, which is short for ceiling. What that does is it takes whatever comes out of this divide and it's going to round it up to the nearest full integer. So we're going to get no decimals. We're then going to clamp this between a 1 and 2 to make sure that we get specific numbers. We don't want anything less than 1, but we don't want anything higher than 2. And what we're going to do is we're going to multiply this by the scene texel size. There we go. Plug that into there like so. There we are. And then we are going to take this and we're going to comp mask this. So just type comp, we get component mask. We want 2 of these, plug the multiply into both. The first is just going to be R for red and G for green for the second. Then what we're going to do with these is we are just going to append them. So right click, append. And we'll have 2 of these as well. Plug 1 into each, and then hold 1 and left click for a 0 and plug those into the B. So what we've done is we've essentially divided our screen into different squares, all of the same size, and then we're using red and green as coordinates to create a grid, and then we're taking that grid and we're adding it back in to the other channel. So we've only got red value here and we've got green value here. What the append is doing is it's taking 0, which is black, which is 0 red, 0 green, 0 blue, and it's putting them back in. So we're going to then have red being a high number, 0 green, 0 blue, and then 0 red here, high green, 0 blue. So basically color values, but determined by how big our screen is and how big our screen is and how big we've divided the screen into the squares. Okay, so that because we're using the texel size, it's going to work no matter how big the screen is, and we're just using the power of 2 because it's it's a flat texture size. It's power of 2, so it's going to be able to scale to absolutely any screen size that you should be able to muster. Right. What we're then going to do is hold M and left click for a multiply. We're going to do that twice. We're going to plug the appends into each of them. Hold 1 and left click for a constant, and plug that into both. I'm going to set this constant to -1 to reverse the values. Hurry! So we really shouldn't see anything there. It's still just going to be really, really dark because stuff. Right. Now what we're going to do is we are going to get a screen position. We're going to component mask R and G. Then what we're going to do is we're going to hold A and left click 4 times for an add. We're going to plug the mask into each add, like so. Just move these over. Ooh, hello. Move these over as a group. Please be friends. We'll just move this multiply up, and we're going to move this multiply down just so we can see things a little easier. We're going to plug a multiply into one, a multiply into the other, then an append into one, and an append into the other. So you've got an append going into each of them, and an append, one of each. An append in one, a multiply in one, a different append in one, a different multiply in one, and all of the masks here. So what that has just done now is it's getting everything on the screen and checking its screen position based on the values of the grid that we've created. So what is this doing? Comment this. It's creating squares. Yeah, it's creating squares. I had to make sure that was how I spelled squares. Sometimes, you know, brain gets confused. Okay, so we've got those. We've got these adds for the multiplies. So what we're now going to do is we're going to get us some scene textures. Excuse me. With just one selected, we're going to go over to the left here, and we're going to change this to scene depth. And then we are going to multiply this. Multiply, copy and paste. So we've got 5 of them in total. Just one moment. There we are. We're going to plug the adds into 4 of them because we're going to be using the grid data as sets of UVs, and we're going to leave one without anything plugged into it. Then what we're going to do is we're going to get some subtracts. So that's not how we get a subtract. We right click and subtract. Copy and paste this 4 times. There we are. And now what we're going to do is we're going to take the one without we're going to take the one without any UV data and plug that into all the A's. And then we're going to take the color from the others and plug that into the B's, like so. So essentially what that's doing now is it's taking all the data within the grid that we've created and it's removing it from the main scene depth. Okay. Then what we're going to do, hold A and left click, we're going to want 3 adds, like so, and we're just going to add the subtracts back together so that we make sure that every grid has all been removed and then added back into a single set of data here. So that's all nice. Now what we're going to do is we're going to quickly hit this with a divide. Hold 1 and left click for a constant, plug that into the divide. Go on, don't be like that. -300 in here. Now what this is doing, hi James. One of my friends, I forgot Steam was logged in. One of my confuse my brain. Here we go. What this is doing now is it's just going to make sure that our values are really flat, so that we're not going to pick up any of the ambient occlusion or the shadowing, because without this, what we get is some weird outlines that go through the models rather than going around the models. But we want to make sure that what we get is only on the outside of the models themselves. Okay, So we'll move this over because he's getting in the way. You're intrusive. Right. So we have a divide. What we're going to do now is we're just going to clamp this down to between 0 and 1 because we want flat values. Is going to make sure this is grayscale between 0 and 1, which is black and white. Then what we're going to do is we're just going to multiply those values, which is really going to blow the whites out. And we're going to multiply this by 2. We'll just change that to a 2. In fact, we'll hold 1 and left click, and we'll plug this in as a constant. Plug this in as a constant. No, you know you're not running that low. Come on, go away. Plug this in as a constant, and put 2 in there just so that we can see it better. Hello, James again. Pick a game and play it. What we're going to do is we're going to component mask this for just the red channel. There we are. Now we've got that. And now what we're going to do is we're just going to hold M and left click for a multiply. We're going to stick that into the B, and then we're going to do something different. What we're going to do now is we're going to make sure that James goes away. What we're going to do is we're going to make sure that we have a way of making sure that not everything can have an outline, because there's going to be certain things that you don't want to have an outline. You're going to see that when we first plug this in, because I'm not going to exclude anything from the outline, but you'll see it's going to be weird. So what we're going to do is we're going to grab ourselves a, what are we grabbing ourselves? A scene depth. We want a scene depth. There we go. We want a sphere mask, like so. With the sphere mask selected, we're going to set the radius to 3 and the hardness stays at 100. Plug the scene depth into A, and then for B, what we're using is a scene texture. Where is the scene texture? Plug the color into B, and then from this we need to select custom depth. Okay, you see that's down there, custom depth. Although we don't want the entire thing, we want to mask. We just want the R. Boink. There we go, because we just want a singular value here. We don't want multiple different values. A singular value. Then what we're going to do from the sphere mask is we're going to clamp this. Make sure that we don't go under 0 or above 1. Then what we're going to do is we're going to hold O and left click for a 1 minus X. What that's going to do is it's going to invert this value. Okay, so that's now inverted. Then we are going to hold L and left click for a lerp. And then we're going to plug the 1 minus X into the A. We're going to hold 1 and left click to get a constant here. We're going to plug that into the B. We're just going to set this to 1. And then we're going to hold S and left click for a scalar parameter. We're going to plug this into the alpha. And we're going to call this blend weight. And we're going to set that to a default of 1. But we'll be able to change that dynamically later on. So now we've got that lerp sorted out. What we need to do is plug this into the multiply we left alone before. There we go. Oop. There we are. And then we'll comment this out. Highlight and press C, and we say removes custom pass. Okay, so now we're going to be able to tell things not to be affected by this post process. So we're going to just stick that there. Right, the next thing that we need to do is we're going to multiply this again. So we'll plug this in, but this is another multiplier that's going to do something else. This is going to be a fall off. So right now this is going to affect everything everywhere forever. So no matter how far away an object is, it's going to try to outline this. It can get pretty expensive depending on how big your scene is. You're not going to want to be rendering outlines for things that are 1,000 miles away. So what we're going to do is we're going to create a fall off that makes sure that we're only rendering these for a certain amount of distance. So to do this, we're going to right click and we're going to say scene texture, and we're going to change this to a scene depth. Where's he at? There he is, right at the top. Right, from the color, we're going to comp mask just the red, like so. Hold D and left click twice for 2 divides. Plug the comp mask into both. Hold 1 and left click, and we want 2 little things here. The very first one that we plug into the divide, so the top one, we're setting this to a value of 6,000. The bottom one, we're setting to a value of 90,000. Now when you do this, it's not going to say 90,000, or it might not. It's probably going to say some weird, there you go. See, we've got 9e plus 04, which is exactly the same amount of characters as 90,000, so yeah. Just putting that out there. Epic, you can change that up, right? Right? Anyway, what we're going to do, hold O and left click for both of these. We'll invert these numbers. There we are. Then we are going to clamp. Now the top one we are going to clamp from 0.25 to 1. The bottom one we are going to clamp from 0 to 1. Okay. Then what we're going to do is we are going to hold L and left click for a lerp. Going to plug our first into the A, the second into the B, and for the alpha we're going to come back up to our blend weight parameter that we created, copy that and paste it down here. Because this is a parameter, we just want this to be called blend weight. Come on, blend weight. I want it to be the same one. Make sure that it's got the same name, and then they're both going to be controlled exactly the same when we mess with them later on. Plug that into the alpha, and that is that little bit done. We can plug this lerp into our multiplier that we left alone. Just quickly move this somewhere nicer like that. We'll comment this out, call this fall off. There we are. Now we've just got a tiny bit more to do. From this multiply, what we're going to do is we're just going to clamp these values between 0 and 1. If we don't want anything lower or higher, we're going to lerp. Oh, hello. I missed the E. Lerp. Wrong lerp. Hold L and left click. Come on. Plug this into the A. Oh, no, we don't. We're plugging this into the alpha. That's the alpha. My notes just say A for alpha. I confused myself because there's an A here. Oh no. Then what we want is we want to hold 3 and left click. For the 3 vector, we're going to plug this into the B. What we're going to do is right click this, convert this to a parameter. We're going to call this outline color. I'm just going to leave this defaulted to black for now because I don't need it to be anything else. Then what we're going to do with the A value is we're going to get a scene texture. Here it is, and we're going to change this one to post-process input 0. Then from the color, we're going to mask. We want RG and B. We don't want the alpha data here. We just want RG and B. Then from this, we are going to lerp again. Lerp. I've done it again. Just hold L and left click. I don't know why I'm searching for lerp. This is going into our A. Into B, we're going to be putting a color. So we're going to stick in like a sort of browny color, like so. There we go. If you want the exact numbers for those, red is 0.335, green is 0.222, and blue is 0.074 rather. Okay, we'll just minimize that down because we don't need to see that color. And the alpha here is going to be our lovely blend weight parameter that we created earlier. Copy and paste that. Delete the _1 because we don't want this to be a copy. We want this to be the exact same thing. Plug that into the alpha. And then we're going to plug this into the A of the lerp here. Then we can plug this into emissive color. Oop. There we are. Ta-da! Stuff. Right, now we're going to press apply. Hopefully we won't get any errors. There we are. So we've got a post-process volume here. I'm just going to get rid of it. If you need a post-process, over in the modes, just search for post, and you'll go on here. Boop, drop him in. In the search bar under the post-process, we want to search for blendable. Now I'm on 4.15. Before 4.15, blendable will show. After 4.15, it's been renamed to post-process materials. It doesn't actually say blendable in here, but searching for blend will still find it. Under array, we click the little add element. Under choose, asset reference, we're going to right click our outlines and create a material instance. We're going to drag that into there. And if we float on in, we should get some weirdness. Oh, we've got some weirdness. Look at that. So we can see that the outline is working. It's working perfectly well, as you can see. Flip back in. What we're going to do is we're just going to head back in here. And we're just going to get rid of that colour. We don't want that colour. Just let that recompile. There we are. So you can see we've got this nice whiteness going on. We've got this working. So you can see that the black is working. We've got some jitter, but I'll show you guys how to fix that afterwards. So what are we going to do here? Let's get rid of the blend weight, because right now the blend weight is giving us just 1. We don't want that. That was just for testing. We can just do this. In fact, we might just be able to plug that straight into there, but we get the mask error, so we'll plug that into there instead. And now we should not have a colour blasting over the top of it. We should just get a nice black outline. While we're waiting for that, what we're going to do is search for unbound inside of our post process. Tick this so we can be anywhere to see this. There we go. And you can see that our lovely little outline effect is working. You can see that how it's affecting one side of the stairs but not the other side of the stairs. This is because of the depth. It recognizes that these are the same item and it's drawing it around the furthest line. So you're going to get them around the furthest line away. So you're not going to get them on the inside. Basically what this is going to mean is it's going to be that you don't get a nasty outline. See here, you're not going to get one going along this way, but you get one going along the bottom if we didn't have a floor there. Now, earlier while testing this, I had a bit of an issue with the sky. The sky decided that it wanted to also be part of this lovely post-processing effect. It's possible that I've undone that issue while I was testing, so let's see. Did I undo it? I did undo it. Right, so by default, this will be what you get. Oh, all right then. Apparently you won't get it. If, okay, we're going to go with the if. If you see that you're getting the outline effect on the sky, you'll get lots and lots of rings going all the way up of it, all right? And that's because it's being included inside this post-processing effect. And if you open up the sky blueprint and you click on the mesh and you go to the custom render depth pass, you search for custom in the details and you get render custom depth pass. If you tick that, then that's actually going to be ignored by our lovely material. That's what this is doing. It's ignoring the custom depth. So anything that you don't want to get outlines on, you can add to custom depth. I think if we were to test this here, if we were to tick this here, we should be able to just turn them off on the stairs, although it's going to call me a liar. Probably need something somewhere. It's going to call me a liar. Well, I mean, I fixed one issue. Right. The jittering. The jittering is a thing. Now, where do we find this? It's in here somewhere. Now, under post-process material, it's by default after tone mapping. You want to change that to before tone mapping, and that should stop the jittery effect. Although Unreal doesn't want to play ball with me today, so who knows what's going to happen. It might turn out pink. If it goes pink, I'm going to cry, because it shouldn't go pink. There we go. No more jittery lines. Just nice, crisp, solid lines. And if we were to press play, you can see that it's working in-game as well. You can see that as we move around, it updates to match our guy the best that it can. but it's doing a nice job. And you can see that every time the frame changes, it's updating where the outlines are, which means that you're never going to have just a single outline. You're going to get this nice dynamic effect, like the world's being drawn in front of you. This is a really cool effect. So we can go into our instance now. Forgot I had the game sound turned on. Sorry, apologies. And we can change some stuff around. So we can tick on our outline, we can tick on our blend. So we can grab our color, and we can change the color of these lines. Now they're pink. I made it pink! No! Now I have to cry, I promised. No, I'm joking. So you can make these any color that you want to make them. And then the blend should determine, well, it's not determining anything because we got rid of the color. The blend isn't going to do anything. Actually, a little bit. Do we see a little bit there? Yeah, it's doing a little bit. Basically how over the top it's going to be, or whether you can see it in certain places, like so. See how it's now, you can see the full-on lines here now of this object. You see the edges rather than just the verts. So the higher this goes, the more of an insane effect that you can get. But that's the blend. I mean, you're probably not going to mess with the blend unless you want something a bit more dramatic like that. That's quite dramatic. Very Tron-ish, if it was like a different color. Green, yes. So we'll set that back to 1. And there we have it. There is your nice outline effect. There are other ways to do this effect. So we could have it so that every single edge is outlined. I like this one. I could show you guys the other way as well if you want. But there we go. Hopefully this is something you guys can use, that you can find useful and fun to create. It's a lot of math stuff. Hopefully I've explained it in quite a nice way. Hopefully you understand what's going on, that we're looking for the vertices of objects, comparing their depth, drawing UVs, using that based on screen space, and then using those UV points to draw lines between each other. Ta-da! Yay! There we have it. Lovely. I will see you guys next time.